Bismillahirrahmanirrahim. Welcome to Linear Control Theory. This is spring 2021. Today we will go through the introduction of the course. The main objective of this course, the linear control theory, is that it is used in many fields including electrical, mechanical, chemical, and aeronautical engineering, and many more fields. By doing this course, you will understand basically the linear control systems or linear multivariable systems. And there are three main areas in which we will focus. The first is the modeling, analysis, and the controller design for a linear system. And we will do this in both discrete time and the continuous time. In continuous time, we will have signals like x of t, u of t, and y of t, while the same signals in discrete time will be x of, let's say, k, u at k, and y at k. So obviously k is the discrete even. It may be 1, 2, 3 integer, while t is a continuous variable, time variable, where it will be like t can be, let's say, 1, 1.1, 1.2, and so on. So after completing this course, the students will be able to do the analysis, the control, and the design task. And the good thing is they will be able to deal with different systems. And this capability will come because we will see every system from their mathematical perspective, mathematical model. And the second thing the students will get from this course is their comprehension level will increase, and they will be able to contribute in the advanced topics, like, for example, the smart grid, highly interconnected power systems, even the autonomous systems like quadcopters, and many more. The course plan is, we have divided this course into 3 parts. The first part will be based on the modeling and analysis of the linear system. And our plan is to cover this thing in 4 weeks. And I will be caring about the first part. My name is Dr. Mohammed Sabi. The second part will be based on the controller design of the linear systems. And we have assigned week 5 to week 10 for this part, the controller design. And Dr. Imtiaz Hussain will take care of this part. Part 3 will be the linear optimal control from week number 11 to week 16. And Dr. Salman Zafar will take care of this part. So our learning will start from the modeling and analysis systems. After that, you will learn and focus on the controller design. And finally, the third part will be about the linear optimal control. This course will end with a project and final exam. And during this whole learning and development phase, we have planned one quiz and assignment for the first part, another quiz and assignment for the second part, and another third quiz and assignment for the third part. And in between this, you will be given a midterm exam. Now the details of the modeling and analysis of the linear systems. We will first introduce the theory of the control systems, the linear control theory. We will go through some of the mathematical description of the systems. And for And for this, we need to go through a little review from the linear theory, linear algebra, to deal with the linear control theory. We will focus on the state space realization. The course will focus on the state space realization. And we will also deal with the stability, controllability, and the observability. So this whole thing, after learning all these aspects, what you will be able to understand is such kind of the simulation model. For example, this is in MATLAB. And in this model, you can see we have a source feeder here, 11 kV. And behind this, we have a mathematical model. Mathematical models. We also see the transformer. Of course, this transformer is implementing all the equations behind this box. We have a load, mathematics is there. So this whole thing will be easier for you after doing this modeling. And this is an example of the block diagram, another way to represent the mathematical model. And this is the power system modeling and simulation. After having all these equations and the controller design, you will be able to do few modeling and analysis in the software. For example, this one shows a small portion of a grid, connected grid of a single area. So modeling and analysis basically enables us to deal with variety or interconnected systems, and we can see the overall performance and dynamics. Okay, so this is very important part, and it is so crucial to learn this part. Next comes to the second thing, which is mainly the controller design. And we will start with the introduction of the controller design. And there is a special kind of controller, which is called state feedback technique for controller design. And sometimes the states are not observable. So you will also learn about the state estimators. And there is another one, which is called the pole placement method. Now, this is another example of our application of the state estimator. I'm focusing here. So this may be a complete power grid. And from the power grid, we have a connected SCADA, and we are having all the data here. Having the data here, we can do analysis, we can figure out the bad data, and we can do some kind of optimal power flow and other energy management tasks. And even you can identify if there is a attacker here, and the operator can do appropriately. And basically this state estimator is basically assisting. This will assist not only the system, but the operators to make better or correct decisions. Okay, because it's so difficult to understand all the time. We need state estimators. Sometimes some states are missing, we cannot identify. So the state estimator application is, I just showed you here. The third part comes here, very interesting and very applicable, especially from the economical point of view. In the third part, you will get an introduction to this. This is an addition to our course. You will learn about the LQR, you will learn about the LQG, the Gaussian and the quadratic regulators. And this is an example of the scenario in which this optimal control applies. This is an application. So in this application, you can see like a small village, we have water tank, 2 kilowatt solar system, 23 kilowatt another solar system, 3 kilowatt wind turbine, we have solar, we have wind turbine and diesel. This is oil, 100 kVA, and we have battery system here, battery storage of 140 kilowatt hour, and this is a small village. Now the problem is, in this application scenario, consider a microgrid. This is a microgrid system and comprised of diesel generator, photovoltaic panels, battery energy storage system. And the aim is to satisfy the energy demand, the power load from the villagers at all times while minimizing, this is important, here the optimal will come, minimizing the overall diesel consumption. So this is a kind of optimal problem that the optimal control will solve. And basically, just to complete the argument, this problem actually falls under something called the switch systems, and it can be solved by using the dynamic programming approach. So having the optimal control background and understanding, you see, you can deal with, you can make the right and the best decisions in such multivariable sort of dynamic system. Okay. The reference material that we are basically focusing on is by the linear systems theory by Chen. We will also use instructor notes plus slides like this one, and some of the research articles, and maybe some simulation softwares. Okay, of course, MATLAB and others, Power Factory, for example, maybe MATLAB and some others power related softwares, for example, Power Factory maybe, or we will see others. The class mode will be hybrid. So we will have some recording lectures, like this is the one that I'm doing, and we can have online question and answer sessions. We will be meeting over Zoom or Google Meet, and all the lecture slides and other materials will be uploaded on the LMS over the DSU. So you can go directly lms.dsu.edu.pk and then log in with your email and password. The evaluation is divided into like quizzes, maybe 3 quizzes, okay, 5 each for each part, and similar for homeworks, 3, 5 for each part. And then there will be 1 project that will comprise the 3 parts, and then the final exam of 50 marks. My name is Dr. Mohammad Sabi, and this is my email address. If you have any questions, please let me know. Thank you.